Hi, today we're going to see how trie structure works. Okay, so this video is not, I will not give you how programmatically the trie works, but I'll just tell you in layman terms what trie is actually. Okay, not it's not like I'll explain from the beginning what data structure is and all that stuff, but I assume that you know what a data structure does, but if you have no idea about, or if you have not heard about the trie data structure, then this video is for you. Okay, so let's begin with the basics. Okay, so what generally we all know data structure is something where the computer finds useful to process the data efficiently, right? So if there is some access to the memory the computer is doing, it has to do the access in an efficient manner. Okay, so in order to do that, data structure will be helpful. Okay, so in general, when I say access, it means the CRUD operation. Okay, create, read, update, delete. Okay, so when 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 trie is used in a in the as a data structure, it is usually it will be useful to retrieve the data in order to autocomplete. Okay, so let's assume a scenario where you're typing something in a search bar, and you're wondering, you don't know the how do you don't know how to spell the word completely, so you just entered some characters. Okay, so when you enter some characters, the computer will try to autofill the word such that it will help you spell correctly. Okay, such that you will not write a word in a wrong manner. Okay, so in particularly in those scenarios, try will be very useful. Okay, so there are other use cases where an efficient try also will be helpful, but we will today talk about the basic try. Okay, the efficiencies will change once the try is modified in a very efficient way, but I'm going to talk about very basic try. Okay, so let's assume you have a search bar. Okay, so you're trying to, in this video you can see, in this on this board you can see I've written VIR. Okay, in the same way you're going to enter in the computer the characters VIR. Okay, when you do that, obviously in the database these words will be there, as these are more prominent. Okay, in our day-to-day life, we will use these words. Okay, especially these are names. Okay, so these will be useful especially in India. Okay, so obviously these will be stored, but in an efficient way the computer will store it in trie structure. Okay, I'll come about in some moment. I'll come there, but let's assume these are the only names which are there in the database. Okay, you obviously there will be more words, but let's assume this is the list. Okay, so if the data structure only has only these names are there, then only these four will be auto suggested when we use try. Okay, because when I end at R, it means that it has to fill auto suggest you these remaining letters. Okay, but interestingly, this will not be coming because it is not ended with R. It doesn't have R at least. Okay, so and in this order, in the third character is not R. Okay, so that's why when I say VIR, all these are being listed. Okay, except Vipin. Okay, so in this you can see interestingly VIRU, this is there, this is matched, and Viren and Virendra and Virat. Okay, so these four are matched. Okay, so when these four are matched, you will select at least one word. If you are interested. So and then the result will come up based on the business logic. Okay, so let's come to how we actually structure the data. When I say structure, it means I'm interested only on the operations. Okay, these are the operations: create, read, update, delete. Okay, So before proceeding to search, insertion, or deletion, I just want to tell you that usually the tree will be very huge. Okay, so this can be the tree. Okay, I'm just printing the sub tree of the very big tree. Okay, so I'll use this particular uh, uh, workplace to tell you how to insert, delete, or search. Okay, so now let's take this particular case. Okay, during insertion, what actually how the logic should work is something like this. Okay, let's say the database has nothing. Okay, and you're feeding, and something has to be inserted in the data structure, right, in order to efficiently search. So let's take virat as a word which is being fed into the system. Okay, now what happens is this virat, it'll actually, we will take each and every character sequentially and try to insert in the tree. Okay, now let's come to v. Okay, what happens is obviously the algorithm tries to go from the root, and let's say since this is v, it will try to check the root, and obviously here we have to let's say this is the root. Okay, if this is not there, I mean, if this is not matching with V, what happens is there will be another structure which will be created for that. Okay. But for the time being, let's say the root matches with V. Okay. If it matches with V, we have to go to the next child of this particular V node. Okay. So let's take here the V, and we will check how many children are there for this particular V node. Okay. Let's say there are there are 3 children. Okay, then what happens is, since this is matched, we will obviously take the next character and try to search the character value with the children here. Okay, if it is matching, then we will strike off this and we will simply go to the next word. Okay, if it is not matching, then what we will do is we will just add another character here. Okay, another character, and then since it is not matched, since it's a failure case, what we will do is we will just enter all these characters simply. Okay, like that we will just enter all the characters, because there is no I node as of now. We will just enter all the characters as it is. Okay, that's how we do the insertion. Okay, now let's say there is another case where I have something like this VIR and I don't have A and T. Okay, so what happens is when I'll just insert, I'll just process the tree in a way like I'll strike off each and every character, and there is no A. So then what I'll do is, since till here I'll traverse the tree, and then just I'll add a node. If there is no A, I'll just add a node and I'll just assign it as A. Okay, this is how the insertion works. But let's say you're going to let's say there are with VIR, there are some other words that are coming up, right. Here you can see Virat, here you can see Viren, here you can see Viru. Okay, so what happens is when you are entering VIRU, Viru, he will come here and you will find that there is no node with character U. Okay, so then what you will do is you will create another child to this R, and then you'll just assign it as U. This is how the insertion works. Okay, now let's come to how search works. Okay, I have given VIR. Okay, now what happens is, as per the explanation which I've given you now on how a node is inserted in a tree, in a trie tree, I have constructed this tree based on the word list given here. Okay. So now I got these 5 words, and you can see here VIRAT, VIREN, like that. I have covered all the words. Okay, as per the instruction. Yeah, I mean, sorry, insertion explanation which I have given. Okay, now I need to search for the words which are starting with VIR. Okay, so now what I will do is I'll go from here VIR, and then what I'll see is I'll try to fetch up this tree. Okay, to show the results. Okay, but there is a small thing which you have to know here. Okay, each and every node has something called false and true. Excuse me. So what that will denote is it will tell you whether in that particular path, whether it has to stop at somewhere, saying that it is one of the words which you have to put in the list. Okay, so when I see, if you look at carefully, there are 5 words. Okay, here you can see there are 1, 2, 3, 4, 5 truths. Okay, which means it says that when a node is ending with, or when a node says it is having this particular thing is word. Okay, is word. Okay, as true, it means that you have to consider from the beginning till where you are in that path as a word. Okay, so what you have to do is you will come here, and you from there you will try to fetch all these paths. Okay, so when I come here, during the insertion, let's assume that VIR is actually one word. Okay, what happens is in that case, when you are inserting VIR during the insertion, you will make this particular thing as true. Okay, if you make this particular thing as true, in this particular thing I will list VIR itself as a word. Okay, I mean in UI you can show in that way. Okay, so in this particular case, this is false, so this is not a word. Okay, so in our search bar we have entered VIR, so these things we have to consider. Okay, I'll give you how we are going to fetch that. Okay, I'll tell you. Okay, so VIR is already there. In the array list, you have to consider this particular path. Okay, so what I'll do is I'll try to check A. A is not, and it doesn't have any is word value as true. Okay, so this is not a word, so I have to go and continue. Okay, this is T, so I need to put in the string. Okay, and I can already see that this T is having is word as true. Okay, so I need to stop there, and I need and it seems like this particular thing I have to consider that as one word. Okay, now come to E. Okay, you have to write in the same way E, then you go the next node, and interestingly you can see this is true, which means I have to consider En as another word. Okay, then since the list is not ending, you have to copy this and put it in another string. Okay, because still the path is there. Okay, so now the next node is D, R, and A. Okay, so from these two paths we have created 3 words. Okay, then the other path there is only one, which is U. Okay, these are the 5 words which we sorry, these are the 4 words which we got. Okay, so that's why we filled it up here in that way. Okay, this is how the search of trie structure will work. Okay, now let's come to delete. Okay, let's delete Viru. Okay, what we will do is in the delete case, we will just follow the same case how we followed in case of insertion. We will just go through the tree and come to come to the path. I mean, come to the node which is the last character of the word. Okay, which is here. Okay, so now what we will do is we will obviously, since it is the last character, the is word will be true. That's 100%. Okay, what we will just do is we will make this as false. Okay, and this is very important. If there is no child for this, we will just delete it. Okay, and we will go to the uppermost, the next upper, I mean, we can call it as parent, and then that particular node also we will analyze. Since that also has, since that has children, we will not do anything. If that also doesn't have children, we'll just remove it and we'll keep going on. Okay, that's how the delete of word in trie structure will work. Okay, I really hope you guys understood how trie structure works. The CRUD operations on trie also I've explained. I really hope that you got it. Thank you.